In our first way of learning of how to solve quadratic functions, solving by graphing, here's what we need to do. We need to take the equation that they give us, and we're going to get it set equal to 0. So it's probably not going to have a y in it. It's probably most likely, and sometimes it will have a y in it, but we want it set equal to 0. So if it doesn't have a y in it, get it rearranged so that it's all on one side with a 0 on the other side. It doesn't matter which side that is, and in standard form. Then we're going to graph the related function ax y equals ax squared plus bx plus c. So we're going to graph the related function as if that y was there. Okay, so y equals ax squared plus bx plus c, or in other words, we're going to replace the 0 with a y. And then we're going to determine, which we already know how to do also, the zeros of the graph. So there is not anything today that is really new to us. It's just that now we're discovering that the zeros, it says these are the solutions. So once we can find the zeros from the graph, we can say, oh, these are the solutions to that quadratic function, to that equation. Okay? So let's start our process here. Here's number 1, solve. X squared plus 2x equals 3. Solve that by graphing. So what did it say to do in our first step? Get it set equal to 0. So what do we have to do? Subtract 3 from both sides. So we will have our x squared plus 2x, subtract 3, and now we will have that 0 on the other side. Is the left side in standard form?
Yeah.
It is, isn't it? So we have our standard form set equal to 0. Now in step B, we're supposed to graph the related equation. So we're going to take that, and instead of having it set equal to 0, we're going to set it equal to y. So we have to get everything onto one side. We'll have 0 on the other. We're going to graph the related equation. We're going to replace that 0 with a y. We're going to change any subtraction to add the opposite, like we always do. And now we're going to identify our A, B, and C. Okay, what's our A? 1.
2.
B, 2, and C, -3. Okay, here's what you just quizzed on. Find the vertex. How do we find the vertex? What's the first thing we have to use?
B.
We have to do our x equals the opposite of b over 2a, right? Isn't that our first move? Use that little formula to get the x value of the vertex. So we have x equals the opposite of, we're going to put a 2 upstairs, and 2 times 1 downstairs. Okay, what does that become? X equals the opposite of 2 over 2. X equals what? -1. Okay. So now we know the x value of our vertex. We need to find the y value. Okay, so now we're going to come over here and we're going to write our y equals x squared plus 2x plus -3. And we're going to substitute our x value in for the x's in it so we can find our y value of our vertex. That -1 has to go in parentheses, really important. In here we're going to put in parentheses to show multiplication. So I'm just letting you work because I know you already know how to do this. We just have done all kinds of this. So we just found our vertex, didn't we? Everybody have the same vertex I do. When you're done, you can look up and see if you agree with my vertex or you need to challenge me on it. Anybody get the same thing I did? -1, ordered pair, -1, -4? Or need to challenge? Okay, let's go put that point on the graph. So -1, -4, put that point on your graph. And what are we going to do next? Draw our axis of symmetry, right? Draw our axis of symmetry. Okay, and then we're going to identify our second point. So remember, our second point is the y-intercept,
which is C.
which is C. So we're going to say that our y-intercept is ordered pair what?
0, -3.
0, -3. C equals -3. That's how easy it is to find our y-intercept. So we'll go put our y-intercept on now. I haven't done my axis of symmetry yet, sorry. Well, that's why, because I do so terrible with lines on here. And then how do we get our third point?
Reflection.
We reflect that point, don't we? So we reflect this point. This one's 1 unit away from our axis of symmetry. So we go 1 unit on the other side of the axis of symmetry, and we have our third point. And then now we are going to get our fourth point.
1.
And we're going to have to decide when x equals something. We have to pick an x value that has not been used. So we've used -1, -2, we've used -1, and we've used 0.
1.
So we want to use 1 when x equals 1. Okay. So then we're going to substitute in to our function again. We're going to put our 1 in. And get your y value. Not -3, where'd that come from? I don't know. What was the x value we were doing? We were doing 1. So, ordered pair 1, 0. My fourth point is 1, 0. How about yours? And then we can now reflect to get our fifth point. So that one is 2 units away from the axis of symmetry, so we'll go 2 units away on the other side. We have points pretty close together, but we still draw a parabola going all the way through the coordinate plane, right? So let's draw a nice parabola now. Okay, this is where we would have been done last week when we were just learning how to graph them. But now we're solving by graphing, so we're not done yet. We have to show what x is equal to. What are the solutions? Okay, so our solutions are our zeros. So we're gonna say, you know what? There's a 0 there. There's a 0 there. So the solutions, there are 2 of them. We have 2 solutions because there are 2 zeros. So we have 2 solutions. We have x equals what? What's one of our zeros?
-3.
-3. And x equals
1.
1. Okay, but we're not done until we check them. Okay? Because you know what? We can graph incorrectly and think we have the right solutions, but we have to check them now to make sure. So do we need to check this one, do you think? X equals 1?
No.
No, it was one of our points. We already really found the y. I'm not going to make you check. We don't really need to check that one. So we're going to show check. But the reason we're not going to check x equals 1 is because it was one of our points. If the 0 you get is one of the points that you, in your working, in one of your 5 points, then you should not need to check it. Because you've already used it to get the y value. And is this a 0? When y is equal to 0, does this represent a 0? Is this on the x-axis? How do we know it's on the x-axis? Brighton?
Because the y is 0.
Because the y is 0. And when we're checking them, that's what we're checking for. We're checking that if we put it into the equation, do we get 0 for y? Well, we did. So now let's check our other one. We're going to check y equals x squared plus 2x plus negative 3. We're going to check our other 0, which is
Negative 3.
negative 3. Has to go in parentheses.
Y equals
What is negative 3 squared?
9 plus
9. Okay, and what's
6
that's negative 6.
plus negative
Okay.
3. Y equals 0.
What's 9 plus negative 6?
3.
3.
0.
What's a number plus, that's a nice, lovely plus sign. What's a number plus its opposite?
0.
0. Y equals 0. It checks out. And we're actually going to go over here. Let's just put a check mark by over here to show that's our other check problem right there. Okay? So we had to check the reflection point only because the other 0, the other solution happened to be one of our points that we found. That does not mean that both of them are not solutions. We still have 2 solutions to this quadratic function. 2 solutions that make the equation equal 0. Right.
Okay, so for mine, I added the negative 6 and negative 3 and got negative 9. So it's negative 9 minus 9.
So negative 9 plus 9.
Yes.
Okay. Are those still opposites? And that became 0, so that's okay. Can we add in any order we want? Absolutely. There's what property allows us to add in any order we want? Let's see.
Commutative?
Commutative property.
So you,
One.
so you want the work on the assignment?
Yeah,
Is that what you're saying?
we gotta show the work to get the graph,
Yeah.
to find the zeros, and then we have to show check problems for any of them that were not part of our work. Okay, and then you make sure that everybody right now, somewhere on your paper, you can boldly see this is the answer to this problem. The answer is, the solutions are x equals negative 3, x equals 1. We are solving now. And it's gonna get lost in all of that stuff we just did. Any other concerns? You've had some good ones, good questions. Let's go to the back then. We're going to practice a couple more, make sure that we remember how to do, sometimes we have different types of things that happen. So we're going to solve x squared equals 9 by graphing. Okay, what do we have to do first?
Equal to.
Gotta get it set equal to 0. Okay, so what are we going to do to make that happen in this one? Subtract 9, okay? So now we have x squared, take away 9 is 0. Okay? Step B, what do we do in step B? Replace 0 with y. Okay, so I like to just also turn the equation around and have the y started out. Y equals x squared minus 9. Instead of being set equal to 0, we want it set equal to y. We'll change this to add the opposite. And see that we have an x squared plus a negative 9. Okay. What's the a value?
1.
B,
0.
0, C,
Negative 9.
negative 9. Okay, stop right there and let's reflect back to what did we learn? When B is equal to 0,
It's
what
always-
is true? Schmarky?
The C is always your vertical, what do you call it? Like vertex.
Okay.
Like,
So
oh
the
yes.
vertex will always be the y-intercept. Yeah, the vertex is going to be y-intercept. So what's our vertex?
0, negative 9.
0, negative 9. We don't have to work any harder than that. We're going to have to work harder finding some other ones because do we get to reflect that point?
No.
No, we don't. So let's go put that on our graph first of all. 0, negative 9. Draw our axis of symmetry so that we remember that one does not reflect. Does not reflect. We're going to have to find other x values that we can plug in and then reflect those. So, what x value have we not used that we can start with?
1.
1. Okay, let's use 1. So we're gonna do when x equals 1. So y equals x squared plus negative 9. Y equals 1 squared plus negative 9. Y equals 1 plus negative 9. What's our y? Negative 8. Okay. So we now have ordered pair 1, negative 8. Not very far away from that other one. 1, negative 8. Oh my lord. It's so fun being located right next to the zoo.
I know, it's like,
Brighton.
it's like a teacher.
Could we do 3?
Okay, we could, but what are we going to do before we do 3? Reflect this one. Okay, so let's reflect this one first. Okay. And then, Brighton, why do you want to do 3? Why don't you want to do 2? Go ahead, Brighton.
Because then it'll move it further out and
Yeah.
make it easier to
These are
grab.
so close together. And what is it that we're looking for today? What do we want to find?
3 points.
We want to find where it crosses the what?
X-axis.
X-axis. Well, chances are, if just, just kind of like using some common sense, if we would use 2, chances are it might not even make it up to the x-axis yet, right?
Yeah.
So let's be a little bolder and let's move out to x equals 3. You can use x equals 2 if you want. I'm not saying you can't, but chances are x equals 2 is still going to be a point below the x-axis.
So you
And
can,
then when that happens and you're trying to figure out where it's crossing the x-axis, it's going to be harder to tell. Okay? Because you guys aren't really good at drawing parabolas, first of all, yet. You kind of have some funny looking ones. You just haven't had enough, practice yet. So let's just be crazy and let's do when x equals 3 instead. So you get to pick your x values. I let Brighton pick. And I get 0 for y. What do you get?
0.
Okay.
So,
Oh, what's that called then? What's this point called?
3,
Well, what's it called? Yeah, it is ordered pair 3 zeros.
vertex.
Is this one of our zeros?
Yes.
Yeah.
It sure is, because look at where it's going to go on the graph. 3, 0. It's going to go right there. Is that on the x-axis? Yes, there's a 0. Have we just found one of our solutions? We just did, didn't we? Okay. So we're going to reflect that one also. So that is 3 units away that way. So it's going to be 3 units away on the other side. So good call on Brighton's part, because it just so happened that it went right. I think we got our zeros that way. Okay. So solutions are x equals what? Negative 3 and x equals positive 3. Okay, there's our solutions right there.
You don't have to show
Do we have to check the 3? No, we don't, because Brighton was wise enough to say, let's use it in x equals 3. So we've already done that one. Check. Okay, but we have to do when x equals negative 3. So we're going to check that one out. So we have x squared plus negative 9. So y equals negative 3 in parentheses squared plus negative 9. What is negative 3 times itself?
9.
9. What is a number plus its opposite?
0.
0. Does it check?
Yes.
Because that's what we want to happen, don't we? Y has to become 0. Trey,
If it's gonna be like that, like 3 and negative 3,
do we have to check that other one?
yeah.
Yes. Thanks for asking. Am I letting you know to check in one of them? If it was one of the points? Yes, I am. Okay. I didn't let last year, just so you know, you could feel a little bit, better. Okay, let's do one more together here. Okay, what's going to be our first move?
Get it. Y by itself. Or X
Y is already It's already equal to
It's
zero.
already done,
It's
so
already said equal
your,
to 0?
your A's and
Okay,
B's.
do we have to do that?
No.
Okay, no, we're not gonna do A and B yet, we have to
Y equals X
change
squared.
the, yeah, we're gonna get rid of that 0 and replace it with a Y and change any subtraction to add the opposite so we're more successful. And then we'll do A equals B equals C equals. 1 for A,
-2,
-2 for B,
1.
1 for C. Is the y-intercept the vertex this time?
Yeah.
Is the y-intercept the vertex this time?
Y
No, when
equals
is the y-intercept the vertex? Or when is the
When B
vertex
is
the
zero.
y-intercept?
When B is zero.
When B is 0. B is not 0, so we have to find the vertex first, okay? So we're going to do the vertex.
Does negative turn out to be
What step are we on? Are we on step B, graphing? Yeah, we are, aren't we? Okay, so the vertex, which we're going to have to do x equals the opposite of -2 over 2 times 1.
So equals to -2.
X equals the opposite of
2
-2 over 2.
equals
Opposite of, what's this become? -2 divided by 2.
-1.
-1. So what's the x value of our vertex?
1.
+1. So now we'll go over and do our y value. Y equals x squared plus -2x plus 1. What's our vertex? 1, 0. Okay, let's go put it on here. What are you going to draw next? Axis of symmetry. Anybody want to quit now? Say we don't have to go any further? You want to quit now? Brighton?
Since it's the vertex and it's already on the x-axis, doesn't that mean that it's only going to be that one point that's on the graph?
So is this one only going to have 1, 0? Because does the vertex have a reflection point? No. And from the vertex, it either opens up or it opens down, right? What is this one going to do? Open up or open down?
Open up.
Open up. You know, I'm going to be so nice to you. I don't even think I did this last year either. Look at this. Because we're so smart, we know that that vertex is not going to have a reflection point, and we know that it's going to open up. Why is it opening up again?
Because it's positive.
Isaac? Yeah, there's so many it's in this world. Isaac?
The A value is greater than 0.
The A value is greater than 0, so it has to open up. And they get this time is the parabola, has to open up. And so, you know what? I think we already found our solution. It is, there's only one solution this time. It is what?
1.
X equals 1. Right?
Would we have to do a check problem for this one, or since?
Just like that. We already did, didn't we? Oh, that was a nice one. Love it when the vertex is on the x-axis. Okay. Any other questions? Okay, but you have to be able to, you know, process this properly. Now, what happens if, let's have a scenario here. What if you're working along and you've got your 5 points and none of those points are on the x-axis? Does that mean there's no solution? Because none of your 5 points are on the x-axis, but yet, if you draw your parabola, it does cross the x-axis, right?
Couldn't you do more dots, like?
Yeah, that's what I would suggest you do. Use some critical thinking and say, wait a minute, now if I would just do, but the last one on here, the x is equal to 3, and it still isn't quite reaching, it's opening up and it's still below the x-axis, maybe if I did 4, why don't I just try 4 and see if it works? Because if it works, it's kind of like you're doing your check problem anyway, aren't you? The other option you have is if you don't want to do that, then you're going to draw your parabola and you're going to see where the parabola crosses and you're going to have to check those numbers where you think it crosses until it works. Okay, so sometimes it's just easier actually to go past 5 points. Look at here, this time we only had to do 1. There's going to be other times maybe you need to do more than 5 points. Maybe you're going to have to do a 6th point and reflect that one. Okay, so don't get, boxed in. I already let you out of like this one, not doing all 5 points. So sometimes you just need to go beyond 5 points though, and do some extras to help you get a good 0 or a good solution for the function, okay? Any other concerns or questions? You've had some good ones. Okay.